In this video, we'll talk about how to find the inverse of a 2 by 2 matrix. So if we have the following matrix A, and it has values A, B, C, and D, the inverse of A can be calculated by using the following formula. 1 divided by A times D minus B times C, and we multiply by the following values. We switch the D and the A, and we add a negative sign in front of the B and the C. So let's work through a few examples of how we can use this formula to find the inverse of a 2 by 2 matrix. So let's say that A is equal to the following. It has the values 4, 5, 2, and 3. How can we find the inverse of this matrix? Well, we can write the inverse of A is equal to 1 over A, in this case, is 4, and D is 3. So we say 4 times 3. Minus B times C. So B is 5 and C is 2. So we have 5 times 2. And we multiply that by, notice we switch the D and the A, so we'll switch the 4 and the 3. And then we simply add a negative sign in front of the B and the C, so the 5 and the 2. So negative 5, negative 2. Okay, so we get 1 over 4 times 3 is 12, 5 times 2 is 10, so 12 minus 10 is 2. So this whole thing becomes 1/2, and then we still have 3, negative 5, negative 2, and 4. So this tells us that we just need to multiply each value in this matrix by 1/2. So if we do that, we'll get 3 times 1/2, that's 3 halves. Negative 5 times 1/2 is negative 5 halves. Negative 2 times 1/2 is just negative 1. And 4 times 1/2 is 2. So this is our final answer. This is the inverse of the original matrix A. All right, let's try another example. Let's say we have matrix B with the following values, 5, 3, 3, and 2. How can we find the inverse of this 2 by 2 matrix? Well, we can write B inverse is equal to, here's our formula once again, A times D, so 5 times 2, minus B times C, so 3 times 3. And the matrix that we're multiplying by is, remember, we switched the D and the A, so we switched the 5 and the 2. So we have a 2 right here and a 5 right here. And then we simply add a negative sign in front of the B and the C. So we have a negative 3, negative 3. So we get 1 over 5 times 2 is 10, 3 times 3 is 9. So 10 minus 9 is 1. So we just get 1 over 1. And then we have these values. Now, 1 over 1 is just 1. So we're saying we need to multiply each value in this matrix by 1. Well, that would just get these values by themselves. So our final answer would just be 2, negative 3, negative 3, and 5. This is the inverse matrix of the original matrix B. Okay, let's try one more example. Let's say we have matrix C with the values 6, negative 3, negative 8, and 4. How can we find the inverse of this 2 by 2 matrix? Well, we can write C inverse is equal to 1 over A times D, so 6 times 4, minus B times C, so negative 3 times negative 8. And then we'll switch the D and the A, so we'll have 4 and 6, and we'll add a negative sign in front of the B and the C. So this negative 3 becomes a positive 3, and the negative 8 becomes a positive 8. So we get 1 over 6 times 4 is 24, minus negative 3 times negative 8, that's a positive 24. So we get 24 minus 24. So notice in this example, this denominator right here is 0. So we would have 1 divided by 0, and that's undefined. So what we say is this particular matrix actually has no inverse. And that is a rule that you will encounter where AD minus BC, this is known as the determinant of the matrix. I'll just write DET. And whenever the determinant is equal to 0, it means that the matrix has no inverse. So that's something to keep in mind when you're finding the inverse of a 2 by 2 matrix.